Okay, this is notes 8-2 in your packet. And so we're going on with Pythagorean theorem. So previously we learned when two sides of the right triangle are known, the third side can be found using our formula of a squared plus b squared equals c squared. And anytime we find that those three numbers are whole numbers, a, b, and c, we call those Pythagorean triple. And so if it gives us a number and we try to find out are they a triple, we just say is 3 squared plus 4 squared. Does that equal 5 squared? That gives me 9 plus 16 equals 25. And yes, that's true. 9 plus 16 does equal 25. So that's one of our common ones where we have the 3, 4, and 5. And it also works when all those numbers are doubled. 6, 8, and 10. If they are tripled for 9, 12, and 15. Another common one is 5, 12, and 13. 8, 15, and 17. 7, 24, 25. Those are all some common ones. If you memorize some of these, like the basic ones, it saves you time in doing math if you recognize them in some problems. If you don't, you just have to know anytime it's whole numbers, we call it Pythagorean triple. Alright, and then the rest of our lesson is just dealing with what types of triangles are formed when we're given some numbers. And so we did this last semester. A triangle can be formed only if the sum of the smaller two sides must be greater than the third side. And we did that activity, talked about if I have a triangle and this is my one side and the other two sides aren't long enough, they can't meet. There's no way to do it. If I have like a 5 and a 1 and a 2, they don't meet in the middle. They would just collapse and have space in between. And so we have to have the sides that are greater than to make the triangle. And so our first step is to just check out 4, 5, and 6. So 4 plus 5 equals 9. Is 9 greater than 6? Yes. So yes, a triangle can be formed. Our next one, 4 and 5 is 9. Is 9 greater than 9? The answer is no, they equal each other. So if we're trying to line them up, if we had the right length of sticks, this is 9, here's my 4, here's my 5. They meet in the middle, but that you can't angle them up for a triangle. And then next we have our 4 and 5, which is 9. 9 is less than 10. And so again, if we were trying to build this with the sticks, we would have our 10. And we would have our 4, and we would have our 5, and they wouldn't even meet in the middle because they're smaller. Whereas this one, when we had it, we could have our 4, our 5, and our 6. It would make a triangle for us. Alright, and turn to your next page, which is the last page of notes for this packet. And so this is going a step farther of classifying our angles by acute, obtuse, and right. And so an acute angle, if you'll remember, is less than 90. Obtuse angle is greater than 90, and a right angle equals 90. So once we've determined if a triangle can be formed, so watch for ones where you just can't make the triangle. If a triangle is formed, we can figure out what type it is without drawing anything, just by doing the math. And the important thing about this is that we are comparing our longest side, so C, to the sum of the square of the shortest side. So it's basically the Pythagorean theorem in reverse, and so C must come first. And so we look, a right triangle is when C squared equals A squared plus B squared. That's what we've been working on. Acute is when that C squared is less, just like acute is less than 90. An acute triangle is when C squared is less than A squared plus B squared. And obtuse is when that C squared is greater than A squared and B squared. So as long as you remember put the C squared first, and remember acute is less, obtuse is more, you'll do this very easily. So here, first step is determine if a triangle can be formed. So we have to add them together. So here, 12 is our largest side, so that would be my C, and this would be A and B. 5 plus 4 is 9. 9 is not greater than 12. It's less than 12, so my answer is no. The nice thing about that is I'm done. I can't classify if it's a no, so that problem is done. The triangle cannot be formed. This one we check. 6 plus 7 is 13. 13 is greater than 8, so yes, a triangle can be formed. So now we do the math. So there's my A, B, and C. I start with my C squared, and I'm doing, is it greater than, less than, or equal to A squared plus B squared? And so 8 squared and 6 squared plus 7 squared. So 64, 36 plus 49. When I add those together, they equal 85. And so 64 is less than 85. So that's my less than, which means it is acute. My next one has a square root of 10 in there, and so I have to know if a triangle can be formed. Is that 10 my largest side, or is 3 my largest side? And so if you don't already know, you can type that into your calculator and do your square root of 10. Find out that's 3.16, so that is going to be my C. That will be my largest side because it's a little bit bigger than those. So this gives me, does 1 plus 3, is it greater than my square root of 10, which came out as 3.16? Yes, it is. So 4 is greater than 3.16. And so yes, a triangle can be formed. That was my first step. Now I have to go ahead and set it up. So C squared comes first. And I'm just writing out the formula again here. So square root of 10 squared. And then I have my 1 squared plus 3 squared. So square root of 10 squared is super easy. Those two just cancel each other out, so I just end up with 10. And 1 squared is just 1. 3 squared is 9. And so I end up with 10 and 10. So they equal each other, which means it is a right triangle. Anytime they equal, it's a right triangle. And last of all, we have it in decimal format this time. So 5.2 is definitely the largest side. We can add those up. 7 is greater than 5.2. And so yes, a triangle can be formed. And I start with 5.2 squared. Is it greater than, less than, or equal to my 3 squared plus 4 squared? So that is 9 plus 16, which equals 25. Now you might already recognize without doing the math that 25 is 5 squared, so 5.2 has to be greater. But we're going to go ahead and do 5.2 squared in our calculator. That gives me 27.04. 27 is greater than 25, therefore this is an obtuse angle. And that is it for the notes for today.